For the function f of x equals negative x squared plus 6x minus 4, a. Find the x and y intercepts. B. Write the equation in the form f of x equals a times the quantity x minus h squared plus k. C. State whether the parabola opens up or down. D. Find the coordinates of the vertex. E. Write the equation of the axis of symmetry. F. Graph the function. And G. Find the domain and range. So we'll go ahead and find the intercepts first. We'll find the x-intercepts first, and we will let f of x equal 0, or we'll set the quadratic equal to 0. So we have negative x squared plus 6x minus 4, and we'll set that equal to 0. I'm going to divide everything by a negative, so we have a positive lead coefficient, giving us x squared minus 6x plus 4 equals 0. And I'm going to go ahead and use the quadratic formula to solve this equation for x. Using the formula, we have x equals negative b. B is negative 6, so negative b would be negative negative 6, or positive 6, plus or minus the square root of b squared. Negative 6 squared is positive 36, minus 4 times a is 1, times c is 4, and that's all over 2 times a. 2 times 1 is 2. Simplifying further, we have x equals 6 plus or minus the square root of 36 minus 16, which is 20. All of that over 2. And simplifying further, we have x equals 6 plus or minus the square root of 20 is 2 root 5, and that's all over 2. And then dividing all three terms by 2, we get x equals 3 plus or minus the square root of 5. So there's our two x-intercepts. You could write them as 3 minus the square root of 5 comma 0, and also 3 plus the square root of 5 comma 0. So there are our two x-intercepts, and I'll draw a box around those so I can find them later. To find the y-intercept, we'll let x be 0, or we'll simply find f of 0, and when we let x be 0, this term becomes 0, this term becomes 0, and we're left with negative 4. So the y-intercept is at the point 0, negative 4. So here are our two x-intercepts, and here is our y-intercept. So again, I'll draw a box around that so we can find it later when we have to graph the function. X-intercepts, y-intercept. Part B, write the equation in the form of f of x equals a times the quantity x minus h squared plus k. I'm going to recopy the original function. Our original function was f of x equals negative x squared plus 6x minus 4. And we want to convert it from this form into the conic section form, where it's a little easier to pick off the vertex, axis of symmetry, which way it opens, etc. So to convert this to the other form, I'm going to do two things here. I'm going to group the first two terms together, and I'm also going to factor out a negative 1. So factoring out a negative 1 would leave us with a positive x squared and a minus 6x. I'm going to leave a space for now, and I'm going to throw the negative 4 outside. So again, I group the first two terms together, and I factor a negative 1 out of the first two terms. And here's where we'll do the completing the square process. So I'm going to take the b position, negative 6, and I'm going to cut that in half and get negative 3, square that and get positive 9. But I have to undo that change because I've basically changed the problem. So what is actually happening here? Negative 1 times positive 9 is a negative 9. Well, I have to undo that by adding 9 out here. And again, I've just created a perfect square trinomial. So rewriting what we have negative 1 times the quantity x minus 3 squared, and negative 4 and a positive 9 is a positive 5. So here is our function written in the alternative form. We have negative 1 times the quantity x minus 3 squared plus 5, and to clean this up a little bit, we could drop the 1 out in front. So we could look at it as f of x equals negative 1 times the quantity x minus 3 quantity squared plus 5. And we'll draw a box around that. There's our answer for part B. Part C, state whether the parabola opens up or down. Well, now I can go to my equation in B. I see that the a value is negative. So since our a value is negative, this parabola opens downward. D, find the coordinates of the vertex. The vertex can be found from the point H, K, which we look at our answer for B. Our H value is 3, K value is 5, so the vertex is at the point 3, 5. Write the equation of the axis of symmetry. That will be the vertical line that passes through the vertex. The vertical line would be in the form of x equals h. So in this case, h is 3, so x equals 3 would be the equation of the vertical line passing through the vertex. We'll go ahead and graph this function. We'll graph our intercepts first. The y-intercept, as you recall, is the point 0, negative 4. So we'll plot 0, negative 4. And then we'll also graph the vertex and our x-intercepts. Now the x-intercepts, we'll have to convert those to decimals so we have an idea of where they are. 3 minus the square root of 5 is approximately equal to 0.76, so not quite 1. So we'll have 0.76 comma 0. 0.76 comma 0 is right about here, and the other x-intercept, 3 plus the square root of 5, 0, that's approximately 5.24. So 5 and a little bit more is located here. The vertex, 3 comma 5, 3 and up 5, 1, 2, 3, 4, 5. And we have an idea now where our parabola is. The axis of symmetry is the imaginary line passing through the vertex. So there's our mirror image line. So a graph will look something, rough sketch, looks something like this. Rough sketch. There's the graph of our function. And finally, the domain and range of this function. The domain would be all real numbers, negative infinity to positive infinity. And the range of this function would be from negative infinity up to y equals 5, including positive 5.